Now, if we continue with black body radiation, we know the curve. We know that the area under the curve is the power given by the equation I said earlier, right? That's the area under the curve, and then the maximum peak here is given by the other equation, and over temperature and so on. But what about the orange curve? What do we have the equation that defines this orange curve? So some classical theories had been developed and to try to understand the shape, but they were not successful. The shape they were getting was like this, and then it will going up instead of down here, as in our curve. But there was this Max Planck that came with an idea, and his idea helped him develop a theory, a model for what was going on, right? The main addition of Planck to the understanding of this was that he said that energy is not emitted in a continuous form, but instead it happens in discrete packages. No, discrete doesn't have to. Discrete packages. Discrete packages. He introduced this concept by saying this. Right? The energy is a multiple of the frequency, a multiple of, and a constant. This is what we call now the principal quantum number that you saw in chemistry. And this is a constant he had to introduce, 6.626 times 10 to the minus 34 joules second, to make his prediction fit the data. The equation he came up with, it's rather complex. It gives you the intensity, it's a function of wavelength and temperature, and you don't have to worry too much about this equation. I'm not going to test you on this. I'm just going to show you what it looks like. Right, so here you have 2 pi h, which is this number, c squared, speed of light, lambda, the wavelength. The h, the c, again, there is a constant here. It's a different constant. It's also related to Boltzmann. It's a different entirely constant, also called the Boltzmann constant. The other one is the Stefan-Boltzmann constant. Temperature in Kelvin and 1. And if you plot this, well, you get that orange line perfectly. Right? If you integrate this, well, you get the area under the curve, the Stefan-Boltzmann curve. And if you take the derivative and take the maximum equal to 0 and stuff, you get the maximum wavelength. So it works. It works. Again, you will not be tested on this equation. You will be tested on these two. But what is very important is this little chunk here. That Planck is saying that energy is not emitted in a continuous form, but in discrete packages. Planck spoke German, so German for package. Oh my God, I cannot even read this myself with this tablet. A package. The German word for package is quanta, or quantum, right? So quantum physics is the physics of packages of energy in this case, right? So nice little equation, well, nice big equation. It opened the door to a lot of stuff after, and then we will come back to this material in the next video.